otherwise, it's also encouraged to use this master method. Okay. So for this one, what we need to compare is O and log BA with the FF. Right. It's all on this slide. It's better you know where it is. And it's compared to find which one is dominant. If the latter one is dominant, so it is this one. If this one dominates, this is the answer. If both of them, they are in the same similar rate, which grows at a similar rate, it's this one. Okay? So you can use the notation. You don't need to put something here. So this is the master method. I already clear about this master method, right? So any doubts here? Okay, so next. Here. Oh, no, it's not this one. Quick sort. Okay, so quick sort is actually one way to sort in a sequence. If you have an array, you should be able to sort it using quick sort. And here's the pseudocode. Okay, so from the pseudocode, what you need to know is, okay, so you have the array, and first we choose one as a pivot. Okay, there's one number which is a pivot, and you always compare with the pivot. So the pseudocode, you can go through the pseudocode. If you have the sequence, you should be able to know how to update this line by line. So one for loop, you will update it once, right? And finally, you can have the I. I is the final position for this pivot, right? Because for the quick sort, actually you divide it into 3. So first, you always choose the first element, right? But later on, when you finally solve for this partition, the partition means this will go here. So this is the final I. Okay? So that's the return I, which is here. And the pseudocode here also solves these things. Kind of sorted, but actually it's called the partition, right? Everything smaller than this is here, bigger than this is there. You can quickly go through this quick sort and see if there is some problem.
For example, after the 6, if we have, for example, 2, so it's going to be changed with the 6.
6?
Instead of 10, if you have, for example, a number less than 6, which is, let's say we have 2, for example.
So first, what do you mean to list up here?
So, yeah, so 2 is going to be first, and 6, we are going to switch together.
So, doing this will be 2?
Yes, 6.
6?
Yes, it's the pivots. I'm talking about the 10. If the 10 is less than 6, so they are going to be switched together, isn't it?
like 5. 5 is smaller than 6, but it's still not going in front of 6.
But if we follow the
Yeah, if you see the 2, when you reach 2, it's still not going in front.
No, but here the I actually is different.
Yeah,
It's the pivot. Let's say the array, the first array is 6 to 13, for example.
First I.
Yes. The pivot is 6. It's still in 6.
Yeah,
But
pivot is
after-
6.
Yes, but after 6 we have 2, for example.
We have 2.
Yes, not 10. We have 2, and the same other numbers. Can I do that?
Yeah.
For example, we have 6, 2.
Yeah. I know.
13.
Yeah.
This is the pivot. Okay.
Yeah, it's a pivot.
So we need to. This is gonna be I, but this is J.
Yeah.
Isn't it? So the next one is going to be 2, 6.
No.
But always 6 is the pivot.
No. This is not this algorithm. This is the pseudocode here.
But it's gonna be always pivot.
But this, yeah, 6 is always a pivot, but we are not changing it at the same time.
It's gonna be here even though 2 is here.
Perfect. Okay. Thank you. Okay. Perfect.
Okay, so,
Thank you.
so see, on the last step, which is here, exchange, this will remove the first pivot. Otherwise, the pivot is always at the first place, right? At the front. Okay, yeah.
Can you do your pivot at the last element?
Hmm?
Can you choose pivot from the last element?
Yeah. Well, that's the,
Last element.
what do you mean?
Can be not pivot, it's the last one, it's not first.
Oh, yeah, but it depends. It's like, I will give you pseudocode or natural find the pseudocode. If I change it, I will write down, I choose this as a pivot.
Ah.
In the exams, usually I will provide you with the pseudocode if it's different from the slides. Okay? Otherwise, I will let you know, okay, according to this. Because you can have your own algorithm, then it's very difficult to see which is the right answer. If I didn't give you the pseudocode, follow the slide. Okay? There are only few questions I give you the pseudocode. Okay? Most of them are based on the slides. Okay, so any more questions about the quick sort?
No.
Okay, if no, then I will go to the next.
Yeah.
So the complete pseudocode for quick sort, right? We do the partition, then we recursively, divide and conquer. This is divide and conquer. And in general, the complexity for quicksort is n log n. Okay, so next. Okay, so next is the hash table. There are two ways, two functions to calculate the hashing we need to know. One is the division method. method, like if I give you some example like this, you should be able to calculate the final key. Division method and the multiplication method. Yeah. So there are in slides in lecture 7. You will find these two methods and how to calculate it. It also has some examples. Yeah.
In multiplication method, r equal to h, right?
제 下面
Yeah, I will go to that.
Here r is equal to h, like hash function key is equal to r, right?
This
No. Here is w minus r.
W minus I, okay?
R, so r is equal to h key. If like
R, you can calculate R.
yeah, I can calculate that, but
Yeah,
r
R
is
is
equal to h key, right? Like the hash key.
This is hash key.
Yeah, but here m is equal to r. So if
Yeah.
as a
So I'll give you IM, then you know how to calculate R.
yeah. So if the question is what is the h cube,
Yeah,
then
kind of things like this. Also for division, the multiplication make. Yeah, I will ask you to calculate the HK. So based on this equation, I will give you the equation, and then you use the equation to calculate the HK. Any question about this part? There are two methods. Yeah. Multiplication method. What? Sorry.
example.
Okay, example. Yeah, okay, I will use this. There are examples. Okay? So first, here we have this equation, right? And with this equation, once you have n, for example m is 8. If m is 8, which already we got r equals to 3, right? R equals to 3. And we also have w is 7. So the last part, right shift, is right shift 4. Right? This part is clear, right? And then we will do these things, A, the product, times K. So for example, this is here, I think it's pure mathematics. Okay, so I will use the reverse way. Right? So it's more like you write it 0, 0. Right? So L fine. Because this part is okay. Because we were doing the mode operation with two W, where W is 7. Okay? So 7 means we kept 1, 2, 3, 4, 5, 6, 7. We don't care about the R before. Okay? On the right shift 4 means this 4 doesn't matter. Run this 3. Will be the hash key. Yeah, this is a hash key. It's already here. This is a hash key. Just follow this equation. Okay? Any more questions about this? The hash function part? Okay, so shall we go to the next one?
Yes.
So we want to make it almost balanced. That's if this branch is too high, so we will do something. Okay? And the difficult part is like when we insert something, it might cause us to recolor and rotate. That's more difficult. And so what we did here is like this. We will insert 15. So according to the pseudocode, the first thing is we need to recolor and keep recolor until we find we cannot recolor anymore. Okay? Or the recolor will not solve it. Recolor will only if it, in this case we can recolor it, but in this case we can't recolor anymore. Okay? And then we will see if it is in case 2 or case 3, or sometimes in the mirror case. Okay? The case 2 and the case 3 has some mirror case. This is case 1. Case 1 do not have any mirror case, but case 2 and case 3 have. So this is more like in the left branch. So there will be the similar thing in the right branch. Okay? We should be able to know there is similar case in the right branch. If in the left branch, like this, you can do this rotation. But if in the right branch, you should do similar rotation. And also case 3. So basically, if you have case 2, you will rotate to case 3. Okay? And if you have a mirror case of case 2, you will rotate it to the mirror case of case 3. And for case 3, you have to, it's not only simple rotate, but actually you change the root to make it balanced. Okay? So for the red black tree, you should know how to, when you insert something, you need to do all the things to make it still balanced or valid red black tree. And the pseudocode here. So it might be better to complete this bit in the slides. So in the exam, you don't need to spend time to think of the mirror case. Okay. So any question about this part? I mean, maybe you can just draw this on your paper and see if you can get it. good way to practice. It's part of pseudo. It's the same with the pseudocode. In this case, it's using this part. So you need to figure out. Yeah. So I suggest you to complete this part. Because this one is definitely the right branch. And the case 2, I mean for case 1, there's nothing about this left or right. For the case 2, it has left or right thing. Okay. Make sure you can rotate it and make the red structure okay. Yeah.
Can you print the tree?
This is the tree.
Yes.
By the way, in the exam, do not draw this black, okay? You can maybe write this is black or something, or adding some B or R rather than black or white, okay? Because you do not make it pure black, then it will be a disaster. When you insert it, you follow the pseudocode, then you know what to do. Okay, so after that, I think that for each chapter we will have more than one questions. So the first one is the geometry method. Yeah. The first one is range searching. So for the range searching, actually there are two pseudocode. One is to find the split load. Okay? We go here to find this, where is the split load? And the code is it's here, pseudocode. Also, the next part is when you find the split load, which should be here, then with the split load, and it is not a leaf, you should be able to draw into the output to see what an output node is. Okay, I think we talk about this in the class. It's which subtree or which branch will come first. The next in this part is widely used. It has a lot of application. Okay? Although it looks simple, but actually with small modification, it can solve a lot of problems. Okay? Such as the check the orientation, or check the side, which side of the object. Basically, it's just using a cross product for the points. But after the checking, after this calculated the sign of this, if it's bigger than 0 or smaller than 0, you can have more application. And then the next one is the sweep line algorithm. So sweep line algorithms, we have some line segment, and we check the intersections. Okay? And what we do is for these vertical lines, we have a set. Okay? We have set. And first we group all these things. Area is here. Yeah, first we sort the segments endpoint by x coordinate, and then looking through. For the left hand points, we check. First we add it into a dynamic set. So this is a dynamic set. So every time you have ones, then you will update this dynamic set. And you are always checking if there are some intersections at the nearby. Okay? So you see, basically because if there are some intersection, these orders will change. So this is sweep line algorithm. Okay.
What if it doesn't cross the line, but it ends exactly on the point? What if it doesn't cross the line?
Which does
For
for
example,
example,
A.
yeah, this way or this way?
Yes.
This
Yeah,
way.
yeah, that's right. It ends exactly on the point. But it
On which
doesn't cross
point?
it. It ends here, exactly on this point.
Oh, okay. I mean, this is a demonstration, okay? But if you check the algorithm here, you'll find it doesn't matter. It doesn't matter. Because this is just to indicate if there's intersection, okay? The order change. Because you will never know where to put this vertical line, right? If you know that, you will already know there is no intersection. But this is just a demo to let you know that if there is some, for example, intersection, this is change, and this change is caused by some nearby lines. Okay, so the order change, then there is intersection. But in reality, you don't know. Okay, there are these things. You're actually going through all this algorithm. And you see for this algorithm, it doesn't have any information about where to start the line or end the line, the vertical line.
Yeah, but the idea
Yeah.
come down. You see from here,
Yeah.
from here to here. Because here it crosses here, so we have A, right? It crosses here, we have A. It crosses here, we have A. So what if it ends here? Will we still?
From here to here is each. So yeah, I think this is a good example, right? But yeah, you see there's a vertical line here, but there's no vertical line here. But where's sorry. Let me show you. This one here. I mean, if you see the left part, it seems that every endpoint, between every endpoint, there's one vertical line, right?
Yeah.
But how do you know how many vertical lines you put here? So it's just a demo to show you if there is a vertical line, the order change.
Yeah, I know about that.
Mhm.
But my question right now is, assuming
Yeah.
this line ends here,
Yeah, okay.
update this one.
Yeah. So it's still.
No, I'm asking you a question, like, I mean, this line ends here.
Yeah.
Is it still the same BACD? Or
Yeah.
different?
Yeah.
The
Still
same?
the same.
Still the same?
Yeah.
Even though the line ends here.
Okay, over here, then you need to remove. Yes, here. In the next slide, you will see. Actually, it needs to remove.
Oh, yeah, that's what I'm asking.
Remove the second.
Oh,
If it's
okay.
end. Okay. So the next one, the print method. I think we go through the print method several times. We know how to calculate the minimum spanning tree. And this is pseudocode. And with the pseudocode, we know how to update. So after the update all these values, you will have a minimum spanning tree. Okay. So okay, the tree is here with a pink color.
This is supposed to be the final tree.
I mean, I think it's better to have a separate one, new one, because otherwise, because this is the edge you need to delete. Right? Actually, you need to delete this 3 edge. Yeah, that's also what I'm looking for. I'm looking for maybe it has a one good example, but not. But at least, first you need to update all these loads. Okay? And then you need to draw this minimum spanning tree. It's up to you. I mean, at least you should draw two things. One is something like this, but with all this updated. The next thing is, because I can't see if this is the right tree on the paper. They can use different color, but you cannot use different color, right? So you should draw a separate minimum spanning tree. I mean, what I mean is, without all this black edge, that's more clear for me to find out, okay, this is the tree. Okay, yeah, we can have a rest. Because this is not a leaf. Here, this is not a leaf. If this is a leaf, we output. Because this is not a leaf, then we go here. The V is the left
Starting
part.
from the left side.
Okay? So if V is not a leaf, it's not a leaf, and we do if this one is smaller than x1 is smaller than p1. So where's x1?
7.
7. 7 is smaller than this,
8.
right? Then we output this subtree, right? You see, we output this subtree rather than 8. So this is over.
So Laoshi, in this case, we first output 17. Because we don't need to
Because
output the
here
nodes.
it's like output, yeah, 14, 17, 17, 14 is fine. Because
Oh,
they're
okay.
all subtree. It depends on which kind of output method you used. Yeah. But the general order is like this. You can write your own operate number, but this one is definitely output first before 8. So it's not in this order. You have some pseudocode order. Okay? So this is for the range search. Let me see some other questions. Yeah, and the next one is some skill which is also clear here. This is the pseudocode, and with the graph, and with the table, you update the tables step by step. Okay. I think most of you are quite familiar with this shortest one.
Well, we don't need to use colorful pen for showing some arrows.
Arrow circles. This graph is provided.
Oh, yes, I mean like the prints, for example,
Print,
we need
okay.
to show print surface size and arrow by red. But you said no colors. We don't need to do that.
Print, there's no color for print. I said red, black tree, do not use colors. And also here, do not use any colors. Yeah, so that's why you need to draw two trees, two graphs. This is the shape within the window, right? Within the window, we need to see if the object is inside the window or not, right? So by doing that, maybe 2 points are in it, but the third point, we don't know if it's in it or not. So we need to find out, we need to cut it or not.
Oh, okay.
Okay?
Uh-huh.
So cutting out is the same with testing if this point is to the left side or to the right side of this window.
Get it?
So this is just this one.
Get it? Right.
So you can see, it's just like one more step. Then you can find out which method to use or which sign means what. Okay? Just this one. If it's outside the window, it's the same with this point. It's on this side of this window. And with these 2 points and this point, you can directly apply this method and give me, okay, we need to cut this point. I mean, in the exam, the question will be more clear. Okay.
So what will be the question?
I don't know. It could be lots.
No, I mean, which way you going to ask the question about this topic? Like,
Something like this. I've already given you 2 examples.
yeah, like you're gonna just say, here's the window, find the third part of the window.
Yes, something like that.
You sure?
Yeah, something like, if this is a question, it should be like that.
Okay.
But I made up this one.
I know.
You probably will ask me, then I made up this one.
Okay.
But for the exam, it's not, yeah, it's more like I give you some more information then you know how to apply.
How many points for this specific question?
Are you planning to do it?
For, I mean, in general,
Yeah.
let's see.
4, 5.
No, not 4 or 5. I mean, each question is around 10 to 15. Each question. So there are 7.
Okay.
So there are 7 questions, ranging from 10 to 15 for each.
So now, in this case, the final answer is gonna be like drawing or just out
Calculating.
Or some number, one
Yeah.
answer as a number.
Yeah, so for example, if you use this one, it's like how many points
Yeah.
construct the face that can be seen. For this example, how many points are in the window you can see?
Maybe like you have to pull like similar question from the exam paper and then maybe demonstrate it to us because
No,
not the same question but similar because you're going to change the numbers.
No. I've already given you 4. That's the rest 3 questions. I will only answer many based on the slides. I will not give you any examples.
But the issue is the which example you just told us we don't understand.
Yeah, but I mean, I can understand what kind of solution I have to provide to.
Like here is so many mix up.
Okay, so one more time about this. Still using this example.
Okay, okay.
Okay, so for example, I give you a lot of points.
Okay, P.
And I give you a set, okay, for each 3 points, we can draw a shape.
Okay, yes.
We can draw a
A
triangle.
triangle, yes.
And only the triangle which face towards you, using the right hand rule. Yeah, so you should know what is right hand rule.
Yes. Yes, sir.
Means you can see it. So how many faces you can see? And list them.
3.
List them.
Oh, list them, okay.
Okay?
Okay.
So like this, but definitely not this one.
You get it?
It's like if you can understand it, it's very simple.
Of